When it comes to demand forecasting, there's an incredible diversity of different methods and different levels of data aggregation that are chosen, both between companies and within. Some forecast on a daily basis, others on weekly, monthly, yearly. Some forecast on a SKU level, others on category level. And this begs the question, what is the right level of data aggregation? This is the topic of today's episode. And before we delve into the answer of this question, Jonas, what are the different types of granularities there are to choose from in demand forecasting?
You have essentially two main dimensions to the problem. The first one is temporal. So it's, do you want your data, your transactional data being aggregated at, let's say, hourly, daily, weekly, monthly, yearly level. And the other dimension is typically the product hierarchy slash supply chain topology. So that's going to be to aggregate per SKU, or maybe per product reference, or maybe per product group, per product family, super family, category, etc. And then you have your locations where you might want to aggregate per site, per region, per country, etc. So, but the two main dimensions are time and then the structure of your catalog slash supply chain network.
So two main dimensions, and we get this sort of matrix of possibilities when it comes to choosing the granularity. Okay. And when we talk about these granularities, what kind of forecast are we talking about when we choose these granularities? Is there a specific type of forecast to fit that?
Yes, I mean what you have, it's a conceptually a model that has been popularized in the 90s with essentially under the name of business intelligence or cubes, hypercubes. So essentially what you have is a way to represent your historical data as vectors. So you choose a level of granularity. Let's say you want to have per SKU per week, and then for every single SKU at a weekly level, you have a vector of values, which, because there is a time dimension, can be interpreted as a time series, and then you can actually forecast this time series into the future. But then, due to the fact that you have many potential aggregation levels, there might be plenty of forecasts that can be made on top of the same data.
So we're talking about time series forecasts when we discuss this problem.
At least this is a mainstream practice in the industry.
Yeah, okay. And what is essentially the timeline in the time? Are they all equispaced, or is it,
so
how do you
equispaced is a super technical term, and most people have never actually, I suspect in the supply chain industry, have never even worked or considered working on time series that were not equispaced. So the equispace is a technicality where you say that essentially your time series is divided into buckets that are completely regular. Although, keep in mind that is a bit an abstraction, because for example, the per month is not exactly regular in the physical sense. You know, the physicists would say, well, there are months that are longer than others. So you see, this is only regular in the sense that according to our calendar, it is completely regular.
Another question when it comes to a month, well, we have different number of, say, Fridays or weekends in a month. And if we see spikes in sales on Fridays, won't that get disturbed?
So here we are getting to the sort of question is, which aggregation level do I pick?
Yes.
You see, so you have plenty of concerns that can emerge. Obviously, there are some aggregation level that have certain effects. If you're looking at data at the hourly level, it might be for most industries incredibly disaggregated, and then it might not even be sensical during the night, because maybe there are plenty of areas where, let's say retail, where nothing happened unless during the night, so it might not even be sensical. Then indeed, if you pick the monthly aggregation is always a tricky one, because indeed you have the fact that some months have 5 days of a given day of the week. You can either have 4 or 5, so that is a tricky aspect that will actually, both introduce some sort of biases in the way you look at the historical data and potentially the way you construct your forecast. But it is also true for the other dimension, the sort of, are you looking per SKU or per product or per category, etc. All sort of that introduce concerns of their own.
So when it comes to these different levels of our data aggregation, can't we technically just choose, say, SKU per day, which is the most disaggregated level, and then reconstruct essentially any other level of aggregation from that?
So first, yes, there is this temptation to go for super disaggregated. In supply chain, it is usually, the most sensical level of disaggregation time-wise is per day. However, it is a decision. It is a fairly arbitrary decision. We could have decided, it was by the minute. And for example, if you're running a call center and you want to look at your arrival rate of incoming calls, you are going to have a much more granular, level of observation for the incoming calls. So it is, again, this is really about what sort of things make sense for the mainstream situation in supply chain. Now, if we go back slightly back in time, we have to understand a bit where we come from. Let's have a look at, a typical store, let's say 10,000 SKUs.
Okay.
In a typical retail network, let's say 100 stores, so it's not even a very large retail network. So we are talking of 10,000 times 100, 1 million SKUs. And then daily data. So if we want to have 3 years worth of history, we are talking of about 1,000 days. So we are talking of 1 billion data points. It's fine, so it is just to represent the daily aggregated data at the SKU level in a modest retail network. And we are already talking of something that is 1 billion data points. So and if we want in a computer, that would be already 4 gigabytes of memory. And thus, when you go back a little bit in time, you would see that this sort of memory capacity were not even accessible before the 90s. And by the way, the whole business intelligence, I would say, as a class of enterprise software tools emerged in the 90s precisely when sort of gigabyte-sized computers arrived on the market. So that was, the two things were going hand in hand. You needed computers that were able to represent those big cubes, and then they were actually software that were just designed for in-memory computing, where essentially it was just a grand word to say, let's take advantage of this newfound, random access memory, and we can operate that. And then based on that, it becomes kind of the default, although we should not forget that it was fairly arbitrary, and when you say it is the smallest level that makes sense, it is, I would say, for supply chain, so this daily aggregation and this SKU level, I would say yes, but you have a lot of edge cases, of edge cases.
Can you give us an example?
For example, if you have a product that is perishable, then the question is that every single day, your stock level, so you can, you just take this sort of aggregation per day, per SKU, but is it sufficient to give you an accurate picture of your stock level? Well, if you're looking at a perishable product, the answer is no. Why? Because actually you may have 10 units in stock, but if 9 out of the 10 units are going to expire tomorrow, then you see that what you truly have in stock is mostly 1 unit plus 9 that are on the verge of disappearing no matter what. So here what I'm saying is that when you have perishability, for example, well, the stock level is not granular enough. And so the SKU level is not granular enough. What you would like to have would be stock level with at least 1 week worth of shelf life, and maybe stock level with at least 1 month worth of shelf life, etc. So you would introduce another dimension. So that would give you, an intuition. And then the time, maybe you see the sort of the daily level is fine, except that there might be stores that are only open, let's say during the weekend, only the morning. So if you don't know that you are actually having a store that is only open, you know, half a day, that you're lacking information. So maybe having this, a more granular information that would be, you know, not data per day, but the morning, the evening, would give you something that is more valuable. Again, I'm just laying out the fact that when we have something that is fairly arbitrary, every single, you know, arbitrary decision about your aggregation level comes with pros and cons. I'm just saying that, you know, that my message here is fairly arbitrary. In the end, there is no grand truth in that. But it's very interesting to understand where does, you know, those sort of decisions come from.
Say we find this most granular level that is within our price, say, reasonability, if that's a word. But then if we have now access to the most granular level that we have, but say we still want to look at a forecast on a weekly basis, for example, can we just reconstruct what we, the level that we want to get simply from the most granular level? The reason I'm asking is because the most data is, of course, found in the more granular you get. So in theory, can't you just, you know, sum it up, your time
Absolutely.
series?
So here we are, again, if we are going back to the raw transactional history, whenever you aggregate, you lose data in terms of information. So no matter which sort of aggregation you're performing, you are actually, this is a lossy process, so you're losing information, so you have less information.
So surely that would make sense that the accuracy would drop, right? The higher the aggregation level we go.
Yes, but so what we have is, okay, this was very much something, the reason why we want to have this sort of aggregation set up, I would say, that is cube-driven, is because we have the sort of software that operates relatively swiftly, and the idea is that when you have an hypercube, to do operations that are slice and dice can be done very efficiently. Again, this is a very technical reason. Thus, if you want to go from daily to weekly, it is a very efficient operation that you can do on the cube, and that's why it's typically set up like that. Indeed, in terms of pure information theory, whenever we go into a more aggregated sort of level, we are losing information. So in theory, if we want to have something that would be a more accurate statement about the future, we would want to operate on the most disaggregated data. However, people would think, oh, the most disaggregated data would be those data per SKU per day. And that would say, hold on, the most disaggregated data is not even aggregated data at all. That would be the raw transactional data. However, the reason why people stop at per SKU per day is essentially because it's the last level at which you're still operating with time series. If you want to go any further than that, and so to deal with the raw transactional history, then essentially you have to give up on the sort of time series perspective.
Why? Why does
because
time
the data is not
series
structured as a time series. I mean, it's literally relational data. So you have like tables in your database. It is not structured as a time series anymore. It is not, and certainly not like an equispaced time series.
So
You
time
see, it's
series,
just
yeah.
time series only emerge when you essentially construct vectors of data where you say per period, that the period can be day, week, month. Per period, I have a quantity. And then you have a vector of quantities, and you want to extend. This is a time series model. If you operate with just a table, which has, 100 columns, this is not a time series. This is just a relational table in a database. This is very, very common, but this is not a time series.
So it's the forecasting method chosen itself that is now another limiting factor.
Then indeed, the question is, why is it so appealing? The answer is that most of the supply chain industries operate with a time series, a mental model. So obviously, if you've decided that everything has to fit the time series model, then the hypercube is a very appealing factor, because everything you're looking at, as long as one of the dimensions is a time, you're always looking at time series one way or another at various levels of aggregation. But here comes the crux of it, is that although in theory, information theory would tell us that the more we disaggregate, the more information we have, and thus the more we can possibly know about the future. Yeah. The reality is that time series techniques tend to, most of them, not all of them, but most of them tends to perform very, very poorly on very sparse, erratic, intermittent data. And thus, the problem is that when you go into very, very disaggregated data, from the perspective of your time series technique, not from the real perspective. The real perspective is you have more data.
Yeah.
But from the perspective of your time series technique, you have a vector that is sparser and sparser, so more zeros. And thus,
time series is about more of the same, right? So
Yes.
we make the assumption that the future is symmetrical to the past. Is that where
I mean,
the issue comes from?
Yes, but this is true for all data-driven methods. So all data-driven methods basically rely one way or another to the idea that what the future will be more of the same. You see, it doesn't really depend. You can say it's machine learning, AI, time series, whatever. It is always the same of idea. All our statistical methods are rooted in the idea that the future will be more of the same compared to the past.
But surely, if you go more granular, you lose out on maybe seasonalities and things like that.
No. The characteristic of the time series is a very technical one. It is the fact that the time series model gives you a highly symmetrical model in the sense that the future, in terms of data structure, look exactly the same as the past. This is something that is very, very specific to the time series. You see, it's when you say more of the same, yes, but I make a statement about the future. This statement doesn't have to have the exact shape and form and format compared to my historical records. So it may, but it may not. With time series is incredibly seducing, but I believe it is also misguiding people a lot. But it is incredibly seducing because essentially the future and the past are the exact symmetric. And when I say the exact symmetric, just imagine your hypercube, your cube. You have a dimension for the skews, a dimension for the day, a dimension for, and essentially the future is just you take your dimension for the day and you extend this dimension by, let's say, 100 more cells. And then here it is. You have the future, and then you would say the forecast is just filling in the gap. And so literally you would say it's the exact same data. There is data that I've observed, and then data where I'm going to fill in the blanks with my time series forecasting model. However, that would be my position. There is a very radical and fundamental asymmetry between the past and the future. And if you go for this, some classical time series average forecast perspective, you are doing something which is pretending that the future is exactly the same as the past. In nature, not only the fact that it's, that it doesn't have happened yet, it's literally in terms of data format, in terms of where to think about it, you're just saying that it's completely the same. And my proposition, which is more like a philosophical statement rather than a scientific one, is that no, it isn't. It is very, very different.
I still see, many RFPs. They ask vendors, can you give us all of these levels at once?
Yes.
They want different levels of aggregation. Why?
Again, it is a standard question. Like people, you see, again, this is the fallacy here is that you start with this time series model. And this time series model has its counterpart in the software industry with business intelligence, where everything is basically a cube or a version that is sliced or diced of a cube. Now, people realize that, yes, we lose information when we go, but somehow they are not really sure why, but their metric tells them that their very disaggregated forecast is complete crap. The reality might be that just because they are not using the right method, it is indeed very poor. So they say, okay, our forecast is super, super poor. So they say, well, we need the possibility to bubble up to some higher level of aggregation. It's going to be maybe per week or maybe per product instead of having per SKU. Okay, so, but they don't know which one they want to pick. So when they ask a vendor, they want to keep their options open. And so they end up with, unfortunately, semi-ridiculous RFPs where they end up having, 100+ questions where they want to have all the aggregation levels, just because from their perspective, they are keeping the option open about at which level they want to apply the time series forecasting model. But here, I really challenge the very fact that why should you even aggregate your data in the first place, and why should your forecasting technique start to discard data in the first place before it even starts to operate? You know, you're losing data, so this is a problem. And aggregating more is just making you lose more data. And then if you say, but wait, we can't operate at a super disaggregated level because our metric, which is percentage of error, tells us it's very, very bad, would say, yes, but you're not optimizing percentage of error.
Yeah.
You want to optimize dollars of error.
But you're looking at the metric of percentages, so it's kind of misaligned with the dollars.
Yes, and exactly. And so, because if you go with this fallacy, you would go from day to weekly, you get better accuracy, then weekly to monthly, better accuracy, then weekly to yearly, and then people say, oh, hold on, yearly forecast? What I'm going to do with yearly forecast? This is.
If you make decisions on a weekly basis, how is a monthly forecast going to help you?
That's the problem. That's the problem. That the reality is that the only relevant horizon is the one that is relevant for your decision. But let's have a look at a very simple decision such as inventory replenishment.
Yeah, give us some example of
what is the relevant
granularity.
horizon? The answer is very tricky. First, you will have the lead times. But the lead time is not guaranteed. Let's say you have an overseas supplier. So your lead times may be...
It's not a constant.
It's not a constant. It's something that varies. So your lead time might be something that is kind of 10-week-ish, but potentially with a potential for huge variations. Some of those variations, by the way, are seasonal. Just Chinese New Year, factories in China closes, so you get 4 extra weeks of lead times. So your horizon, if we're just looking at the lead times, is something that is very varying and would need a forecast of its own. By the way, one of the problems with those time series model is that we're always looking at something that is kind of the sales. All the other sort of stuff that you need to forecast, like your lead times,
They're assumed constant.
It's even worse than that. They don't even exist. You know, your cube don't even represent the sort of lead times.
Just kind of an arbitrarily chosen.
So yes, you end up. So first, you
Horizon.
have your horizon would be your lead times, but your lead times would deserve a forecasting of its own, which do not really fit this
Time
series perspective and cube sort of software. But this is not the end. Should your horizon to assess the validity of your decision only stop at the lead time? No. Why? Because obviously, if you decide that you want to pass a reorder now, you want to fulfill the demand that is going to happen between now and the arrival date of your product, but then you will have to sell what you've just received. So in order to assess the relevance of the purchase order, you have to look at what happens afterward. And how far into the future should you look at? Well, it depends. If the order that you pass, you have a surge of demand, then you might actually receive the good and have everything sold in 2 days. But what if it's the opposite, and then you have like a drop of demand? You may keep the stock for a whole year. Obviously not if it's perishable, but I'm just simplifying. So here you see the horizon. The horizon that is applicable is something that is incredibly dependent on the way you look at the future, and it is a forecast of its own, because it's a forecast because we have to forecast the lead times, and then the horizon that we have to consider, even if we're looking at just the demand, depends on how fast you expect to actually liquidate your stock. Thus, ultimately, there is no clear limits in terms of applicable horizon for your forecast. The only thing the only concern is that the further we look into the future, the more fuzzy the forecast becomes. However, this is a technicality, and at some point, there is suddenly it's not worth investing computing resources anymore. But computers nowadays are very, very capable. So maybe the answer is every single time you look ahead, you look 10 years ahead, and it's just a trade-off that is a pure trade-off in terms of cost of CPU versus potential super marginal improvement for your supply chain. But you see, this is from a conceptual perspective, there is no limit in how far you want to have a look. You want to see. You want to look into the future.
So to conclude this, the level of granularity should always be on the level of the decisions that you want to take.
I would say first. Yes, I would say yes. Your granularity is going to be very much decision driven, but be mindful that this whole notion of having to aggregate is making an hypothesis on the sort of method that you want to use. You see, my suggestion would be you need to keep your eyes on the very decision that you take. So decisions are the things that have a tangible impact on your supply chain. So what are you reordering? Are you moving your price up or down? These sort of things that have, that are not artifacts. They are a real financial, tangible impact on the supply chain. But then I would say beware about the very notion of granularity. This is very made up. This is very arbitrary. And don't confuse your need for visualization, which is fine. You want to be able to visualize the data, and time series are an incredibly powerful tool to visualize the data. This is fine. However, don't confuse this need for visualization with all your other needs that are predictive requirements, optimization requirements that do not have to operate with any kind of I would say, made-up granularity. And when I say made-up granularity, I would say anything that is not just the reflection of the data as it exists in your enterprise systems. Anything that any kind of aggregation that you add on top is going to lose data. So maybe it's going to be a good trade-off in the sense that maybe by aggregating you will save CPU, maybe you will save memory. Maybe that is a good trade-off. But maybe not. But you see, this is a super, super technical discussion. And my suggestion would be don't do some kind of premature optimization, trying to immediately think about those aggregation levels as if they were hard problems. They are mostly easy problems. When it comes to visualization, if you want, you can essentially have, with modern computer systems, it is very easy to have an excess of capabilities with regard to your actual need. So you see, in the 90s, it was a challenge to aggregate the data per SKU per day. Nowadays, it is not. It is not. And if there is a vendor that tells you that they have a limit at 5 years worth of history, this is just super, super weird. There is no such limitation. There is plenty of ways. We can essentially deal with any kind of granularity. We can even deal with the granularities that would be by the millisecond. Obviously, we will not represent by the it's not necessarily something that is super sensical, and you don't want to do that with an actual cube where you're actually using 1 byte of memory for every single cell in your cube. But this is a very technical thing. Modern system will give you any kind of aggregation that you need and more. This is not a constraint. And don't reason by implication, trying to think all the techniques that you want to use based on this cube as if it was the only way to look at the problem. It is not, and there are plenty of things that get lost, perishability, but also what about cannibalization, substitution? What about those varying lead times? So you see, the fact that you frame everything in a cube puts enormous restriction on what you can even think about your supply chain, and this is something bad. So my suggestion is don't put your mind in a cage. Just try to have like a broad.
Because that just adds so many more constraints.
That are yes, very very arbitrary constraints that do not help the problems getting solved for your supply chain.
Thank you very much, Johannes, for sharing your thoughts on this topic. Thank you for watching, and we'll see you next week.